Hey, good evening, everybody. This is Dr. French from Mind Spa coming back to you. I wanted to continue on the topic that we were discussing before. We talked about how the body will mount an immune response peripherally, which can then trigger a neuroinflammatory response. And some of the cells that we had mentioned are a part of that and have a role in upregulating the inflammatory response. Are things like microglia. They're some of the more common cells that we see upregulating pro-inflammatory cytokines. These cytokines are just products of the cell that signal the rest of the body that we need inflammatory cells to come to the site of injury. Where is that site of injury? We have no idea. Sometimes it's very specific, for example, in a traumatic brain injury. But let's say it's less specific. Let's say it's chronic inflammation and the immune system is just turned on for far too long. Then we start to see this environment within our neural tissue that makes it very challenging for our good neurochemicals to make it to their receptors. Things get plugged up, and that's when we start to see issues. There are several well-known cytokines that are part of the inflammatory response, things like interleukin-1, interleukin-17, TNF-alpha, and these cytokines, the products of the cell, are essentially going to recruit more cells, as we just said, right? We have seen through countless research studies that even the exogenous administration of a single cytokine, let's just say interleukin-6, administering that to an animal model will cause what they call sick-like behaviors. You start to see the animal model become less motivated, starting to have less energy, less food-seeking behaviors. And so it's amazing to think that just one cytokine that's given exogenously can cause that kind of downstream effects. Imagine an entire immune response that's mitigated by our cerebral tissues. That causes a lot of problems, and it's important for us to get to the bottom of how to make that better.